Hello and welcome to a new episode of our React Native wallet. In this episode, we will talk about connecting the backend APIs. We have created two new APIs that we are going to talk about them and see how they work. So let's get started. As you see in my last video, we already go through get wallet endpoint. But here I have done some changes inside get wallet that I want to show it to you. Now we have a get wallet balance also. And what this function does, it gets the wallet balance regarding of the BNB coin. So it checks how much BNB exists inside wallet address. Now I want to tell you about a service that I added to our backend. It's a singleton. Singleton are a concept in domain-driven design. When we want to connect to a third party, another network, a database, we prefer to do it through the singleton because it's one point that everyone wants to connect. So it's easier to manage and also it's more efficient. So let's see how we manage this part. I created a singleton under shared folder and name it Web3. This is the place that we connect to Web3 network. As I explained in other videos, to connect to a Web3 network we need a Web3 provider, or Web3 provider is inside config. Then we create a new Web3 instance and then we can integrate. So let's see, one of the function I created here and I want to explain is get wallet balance. Inside this function, first we get the balance by passing wallet ID and then we convert it from Way to Ether, as I told you in other video what is Way and what is Ether. Then we return the balance. The second function that I want to talk about is confirm transaction in the blockchain. As I told you in the other video, this function exactly works with the flow that I mentioned. So I try to go line by line and explain, but if you didn't understand, you can always go back to my other video. So first of all, we need to get the transaction count because we need a nonce. Nonce, it's like a counter for total transactions that you have in your wallet. So for example, if you have 2 transactions, the nonce will be 2 or 3. So next transaction will be added on top of the last nonce. And we use nonce to prevent a transaction for having to prevent a transaction happening twice. Then we have the transaction object that we created. It has a source address, destination address, and also value. Because normally users prefer to set the value in ethers for us. In our case, for example, in BNB, like 0.1 BNB, we need to change it to Way to send it to blockchain. After that, we need gas limit and gas price that I explained before. And at the end, we have a complete transaction. Now, we need to sign this transaction. Let's see. To sign the transaction, we need our private key and the complete transaction that we already have here. After we sign it, we can send it to the blockchain, and if this process is not ending in error, then we know that private key was accepted by the blockchain and the fund transferred. So at the end, we send back the transaction hash to the user. One handler that we created is a start transaction, and the idea of a start transaction is to send, when user wants to start any transaction, we ask them about which wallet they want to send it to, and we send a confirmation code to their email. This function is only for this purpose. So let's see how it will work. So as you see here, we get the user wallet information from our database. We have some error handling here, and then we get the wallet ID and put it in source address. Then we have a function called create transaction. Let's see. Inside create transaction, we will check first, is the user email is a valid user email. Then we create a variable that it's for date of creation of the transaction. We create a unique transaction ID, and we create a transaction secret. This library helps us to create an OTP that expires after 5 minutes or 300 seconds. So we generate an OTP and we save all the info that we have already inside the DynamoDB table: ID, email, source address, destination address, amount, token. A state of transaction is very important because when we create a transaction, we put it pending confirmation. Date created, transaction secret to check if the OTP is valid, and OTP itself. We put them inside the transaction table and we return the date that transaction is created and transaction ID plus OTP. So let's back and see. We get the transaction ID and OTP from transaction info. If we arrive here, it means saving in database was succeeded. Then we want to send to the user how much we estimate it will need gas. You know what is gas, I explained it before. So to estimate the gas, we will use estimate gas function that I have created in other service. We use a try cache here because we prefer to give the user estimated gas, but if we cannot connect to blockchain for any reason, we don't want it to whole flow to fail. So by default it's not available. If try part goes fine, we have a number to give to user. Then we need to send the OTP to the user email. We use a function called send email. I have a video about how we are going to send email to the user. You can watch it. So I will not go through this function here. But we pass the email OTP and all the other things that we need, and then it will send the email to user email address. So it uses AWS SES, as I mentioned in the other video. At the end, we are going to send the API response. And you see I added OTP here because I don't want to, every time I'm testing, I go to the email and retrieve the OTP. I want to have it in the API, but it should be only for the development purposes. So I am sending the transaction ID, email status, and estimated gas. Let's go to the last function that we have added here. It's called confirm transaction. Let's see how this one works. In the confirm transaction part, we are getting the transaction ID and the OTP that we send to user. We send the transaction ID through the response of the API and OTP through email. So if user send us back those two, it means that he is the valid owner of the email. So as you see here, this function will extract the email from the jailability token. I have created a function called getRequestClaim. Let's see how it works. It will check that the event body is what we want, as you see here, and also at the end it will give us back the email. We had this code on the function body, on the lambda body last time, but because now we have 3 functions that are using it, I extract it to a new file because we don't want to repeat ourselves. So there is a clean code rule that called DRY, don't repeat yourself, and we didn't want to repeat this code all over our lambda, so we just extract it here. Thank you very much for watching. This is how we develop the backend API to connect to the blockchain. Next video, I will show you how we are going to connect from React Native to these APIs. And like always, I will share the link to the code inside the repo so you can see the code for yourself. And if you have any questions, I always be happy to answer it in the comments. Thank you.